Hi, in this video I'm going to talk about layouts and controls. And we're going to start with a discussion of controls with views, and then we're going to explore how these controls fit into various forms of layout. First of all, let's talk about views. In Android, every object on an activity screen, in other words, every control that the user can interact with, is a subclass of view eventually. It may be a subclass of view, but all controls are eventually views. View itself is a subclass of object. Any view placed on a user interface can have an ID attribute. And this is used to bind a view to a variable or a property, and we do that by using the findViewById method, as we've seen before. FindViewById returns a view, and it will have to be cast to the type of the control that we want to interact with. So the process is, we set up an ID in the XML file, in the layout XML file, and that ID is placed in r.java as an integer, and then when we find that, we find the view by its ID. It returns that view. It doesn't return the integer. We can't really deal with that integer. We can't change it. We can inspect it, but we can't change it. Now, layouts contain views. They contain other controls. Layouts are also subtypes of view. So views have a subclass of layouts, various different layouts, and then layouts can contain other views, and so on and so forth. There are two basic types that we're dealing with nowadays. As I already said, absolute layouts have been deprecated, so we're really not going to deal with them. There are linear layouts in which controls are aligned either vertically or horizontally within the layout. This is kind of like if you've ever played with struts and springs, then this is works kind of in that way, as we'll see here in just a moment. And then there are relative layouts in which controls are aligned with respect to the center and the edges of the layout itself, and also with each other. Relative layouts do allow more freedom in placement of controls, but it's always a matter of using the least complicated layout that we can get away with. If we can get away with a user interface that uses a linear layout, we should. If we really need to have floating precision of where those controls are aligned, then we need to opt for a relative layout. We can also nest layouts. We can nest linear layouts within each other. We can nest relative layouts within each other. We can nest relative and linear layouts in any way we want to, and we can achieve various results using that kind of approach. So let's talk about linear layouts. By default, when we create a linear layout, if we give it no orientation, it will have a horizontal orientation. In other words, when we place controls on the layout, they will be placed horizontally next to one another. And they will be placed in the left to right order that they appear in the XML file. We can drag controls in the graphical view to change the order, or we can change the order of the controls in the XML view. If we want to supply a vertical orientation, or if we just want to say for sure that the orientation is horizontal, then we can use the Android orientation attribute. And that will control the linear, horizontal, or vertical orientation. So let's look at that. Here I have a linear layout with two buttons. And if I look at my XML file, I can see that I indeed have a linear layout wrapping all the controls, and I have two buttons. The layout has not been specified in the Android orientation attribute. So let's go ahead and do that. And remember that my graphical layout view shows two buttons, left and right. Now, another thing I want to look at before I do that is I have button 1 and then button 2. So button 1, let's just make sure we understand what we're looking at. And save that. So now we see that button 1 and button 2. So button 1 is to the left of button 2. Now if I take button 1 and drag it to the right of button 2, now I have button 2 to the left of button 1. And if I look at my XML, I see that button 2 is above button 1. So the order that these buttons or any controls are in the linear layout will specify the order that they appear. Likewise, I can take button 1 and we'll cut that and then paste it. We'll paste the order back the way it was. I can tidy that up a bit. And now I'll save. And now button 1 is to the left of button 2. If I change the layout's orientation and say Android orientation, I can just wait a bit and it'll give me the list. So I don't even have to learn to spell. Now if I say vertical and save, if I go to my graphical layout, button 1 is above button 2. Likewise, if I drag button 2 above button 1, that changes the order, and so forth. Okay, so linear layouts are really very basic. They will fill their layout horizontally or vertically, depending on this Android orientation attribute, and the order of controls within the layout will stipulate the order within the graphical view. Okay, very good. Let's continue. Relative layouts, as we already discussed, the position of controls is governed by their position within the layout, with respect to the layout, or with respect to the to other controls within the layout. So the basic controls are center horizontal and center vertical. This controls the centering of a control. Align parent top or bottom or left or right will align the control to the edge of a layout. Layout margin top, bottom, left, or right will space the control the specified amount from an edge. And layout align top, bottom, left, right will align the specified edge of the control with the corresponding edge of another control. We also have layout to the right of, to the left of, or to right of, to left of, above, and below will position a control in relation to another control. And with these, we can also use layout margin top, bottom, left, and right to space it, how far it is to the right of, to left of, above, or below. When we have more than one control positioned in a relative layout, and I really should say, as relative layouts get more and more complex, then the layout manager is going to attempt to position them relative to one another as opposed to positioning them within the layout. There will still be at least one control that's anchored to the layout, but the rest of them kind of will float around with relation to one another. This is almost a bug in the layout manager. So what happens is we can set things up graphically, but at some point some things will stop working. So it might be necessary, and it will be necessary in complex layouts, to adjust the positioning manually within XML to get the desired result. Okay, let's look at an example of a relative layout, and I have one here, relative layout.xml. Now, I can place a button, and we notice that I can center it horizontally. I can center it vertically. I can center it in both directions. So let's look at the XML. We see that the button layout center horizontal and layout center vertical are both true. Now let's play with this a bit. Here, layout center horizontal is true and align parent top is true, but also margin top is 82 dp. Let's look at another button with respect to the position of the first button. Here the button is centered vertically and aligned to the right of button 1. So align right uses the ID of the button that it's aligned right with. Here it's aligned to the bottom or below button 1 and to the right of button 1, but margins have to be used. Margin right is 32 dp and margin top is 42 dp. Now notice something. Button 1 is aligned with the layout, the parent. Button 2 is aligned only with button 1. Let's do this. Suppose we don't want button 1. Watch what happens. There is no ID button 1. So it's going to align it in only the way that it knows. And it doesn't have any kind of parent information or anything else. So our layout has gotten goofed up, so to speak. So we have to be careful in relative layouts that we always have an anchor for every, or we're always anchoring to either control or the parent layout. And that control that we anchor to must exist within the layout. Very good. Let's continue. Let's talk a little bit about control properties. There's a lot of different controls, and memorizing the attributes of each can be an impossible job. But we do know that all controls descend from view. So layout and margin and padding and other attributes are going to all be attributes of the view class. Only the attributes specific to the function of a control will be members of that control's class. And this is good object-oriented programming. The view contains all of the common members, and then a subclass of view will only contain new things that work with that subclass. But we can find information about the properties and the methods of any control using a type hierarchy panel. And let me show you as a last example how we do that. Here we have our main activity.java. And I have a button clicked method. This isn't hooked up to anything, but I have it here just to show you a couple of things. Let's say we want to know something about activity. Well, we can highlight the activity and either right-click and select Open Type Hierarchy, or just hit F4. And F4 will show the activity class in the type hierarchy. It'll show what it's descended from, and also its descendants or its subclasses. It will all show in this panel properties and methods that are of activity. List activity is a subclass of activity, and it will only show those properties and methods that pertain to a list activity rather than repeating those of an activity. So this is a good way to get to know our classes and how they relate. Likewise, if we select View and hit F4, we'll see that View descends from Object and has many subclasses. Each of these is a control. So we can open one up and see various image views or various types of progress bar, various types of text views. That's an interesting one because we see that a button is actually a subclass of text view. So, and so on and so forth. So that's the type hierarchy panel. There's one more thing I want to talk about, and that is string resources, because we should always use string resources rather than the Android text attribute with a hard-coded string. So we store these resources in strings.xml, and this is in resource values. They're assigned an int value just like our IDs, and they are assigned in the r.java class. In layout.xml, we get to those string resources. We access them using the form @string, not strings. The file is called strings.xml, but here it is @string and then slash and then the name of the string resource. We should always use these rather than hard coding strings in the layout.xml file. First of all, it silences the warning. And secondly, if we're going to internationalize our application, it's much easier to do so by using string resources than it is by using hard-coded strings. So let's look at string resources very briefly, and then we'll end for the day. In our activity main, we can see that we have two warnings here. Button 1 and Button 2 both have a warning about this Android text attribute. So let's go into strings.xml And I'll show you two ways to define a string. We can add a string resource and click OK, and then we give it a name and a value. So let's call this one button1 text, and then give it a value of button1. Now it's the same string, and we'll save the file, and we can see that we have this string resource here. We can also add a string by going into XML view, and we'll just copy that, copy, and paste. And then this one we can call button2 text and make its text button2, and we'll save that. Now, if we go back into activity main, instead of using this hard-coded text string, we will say at string and then button1 underscore text and save. And that silences the warning. And then again here we can say at string button2 text. So we'll copy that, paste this, and then button2 text. Whoops. And there we go. We'll save that. And now when we go into graphical layout, we see that we're using the string resources rather than hard-coded strings. Very good. So that's it in this video. Thank you for joining me, and I'll see you next time.